Good afternoon. Let's see how you go with this. I'm in my backyard again, and my neighbour has decided to sculpt a wild-looking hedge into a Soviet-era apartment block. So let's see how we go. So it struck me that quite a lot of people were mailing me with some issues they'd had with the homework sheet. And remember, you only have to do the first page this week. The second and third pages will come next week. So these are all alkanes. There's no double bonds or triple bonds here. So I just thought I'd put a few on here that several people had indicated that they were having difficulty with. And the first one is a simple looking one. It's like the Mercedes-Benz symbol of number 4. And we just do what we always do with these, and we take the longest possible chain. And here it could be 3 carbons, but it could be any direction. So it doesn't really matter where we start. We go 1, 2, 3. And so it's propane. But there's one functional group on that. There's a methyl group here on number 2. And so it's 2 methyl propane. It's just a little one, but it gave people a bit of trouble, I guess, because it's quite hard to see which one is the methyl group. So let's have a look at number 5 here. And this gave people a few problems because it's quite hard to see where the actual functional group is. So here we've got a carbon there, and then 1, 2, 3, and here a carbon group 1, 2, 3 carbons, whichever you go. So it actually doesn't particularly matter which one you call the functional group. It could be that one, or it could be that one. Just for the fun of it, let's try this one. And we go 1, 2, 3, 4, 5, 6, 7, 8, 9. And the reason I didn't start from here is that the number where the functional group comes off is lower if I start from the other direction. And it doesn't make any difference whether I start from there or there, but it does make a difference if I start from there. And so it is 9, so it's nonane. And on the 4th carbon, we get a 1, 2, 3, so it's 4 propyl nonane. Now we start to get to some of the big hitters, which cause people a few problems. And let's have a look at this one, because this one, that looks like an ethyl functional group, because most people look at this to 1, 2, 3, 4, 5, 6 and think hexane. But no, we have to take it from the largest possible line of carbon atoms. And so it goes here, 1, 2, 3, 4, 5, 6, 7. So it's actually heptane. But where should we count it from? The answer is here, because the first functional group comes on number 2, whereas if we did it this way, the first functional group would come on number 1, 2, 3. So we start here. We could start from there, or we could start from there. It doesn't make any difference. Let's start from here. Right, so we get the heptane there, and on 2, we've got, I'm going to have to do it up here, 2 methyl, and then 5, and it's another methyl. Oh, so if it's 2 methyls, it's dimethyl. And it's 2, 5, dimethyl heptane. And there shouldn't be a gap between these two, it should be one word, but I just ran out of space there. And now let's have a look at number 8. It's another one of those where we think 1, 2, 3, 4, 5, we think pentane, because that's what we look at when we see the continuous wavy line. But clearly 1, 2, 3, 4, 5, 6 gives us a longer one. So looking at the longest strip of carbons there, it becomes hexane. And we could count from here, 1, 2, 3, 4, and the methyl group will be attached there, or 1, 2, 3, and so we'll do that. So it's 3 methyl hexane. So it's really, really easy to make tiny errors with these and make it look all wrong, but it doesn't particularly matter if you make a little error at this stage. Now, I'm just going to do 3 of the ones where you got the word problems, because the word problems look absolutely hideous when you first see them, even though they're probably actually easier than trying to interpret the diagrams, because there's no tricks. You always know what the longest strand of carbon atoms is from looking at the name. Such as the first one I want to look at number 3 here, which is 4-butyl. And so that one will be a functional group with 4 carbon atoms in a line. And then 6-ethyl. So attached to carbon 6, there will be 2 carbon atoms in a row. And then, whoa, I'm going to run out of space, 2,5-dimethylnonane. So the very first thing I'll do is go 1, 2, 3, 4, 5, 6, 7, 8, 9, and there's my carbons. And I might label those just because I feel like it. And now it doesn't matter which way I go. I could do it from the right, but I'm going to do it from the left because we're all used to numbering from the left, and I don't see why we shouldn't continue with that. We may as well not overcomplicate things. So, attached to number 4, it's butyl. Here we go. We don't count that one because that's part of the main chain. We go 1, 2, 3, 4. 6-ethyl, 1, 2. And then 2,5-dimethyl, 1, 2. And there we are. A pretty complicated looking thing, but it's all in the name. It tells you exactly what it is. So let's now have a look at number 6. And we get 3,3-dimethylhexane. And I think this one confused a few people because it's got 3, 3. It's quite difficult because normally we put the group here, the functional group, whatever it is, on the outside of these. This time we're going to have to do something else. So let's try drawing our hexane, and it's 1, 2, 3, 4, 5, 6. And there's our hexane, and I'll number those because I can. Left to right, because I'll just draw the functional groups where they should be, instead of doing what we did in the first column and have to interpret the diagrams. We just make our own diagram. So there it is, hexane, except I missed out 5, didn't I? Smart. All right. And now we look at 3,3-dimethyl. Now remember, this is actually a 3-dimensional molecule, and so we have to look where it's going to be. I'm just going to do this and this, and that's the answer. Attached to 3, there's one, and there's another. Now I know these aren't the right bond angles, but this is a 2-dimensional representation of a 3-dimensional structure, so it's never going to be completely accurate. And that's the best we can do. And just one more that people contacted me as having problems with, or when they've handed up their work already, I've noticed that they've been getting these slightly wrong. And just one more, and it looks utterly horrible, and it's this. It's number 8, and it's 5,5-diethyl 2,2,4,4 tetra methyl, and I haven't got room to write octane there. So it's pretty easy. I start with octane. I just go 1, 2, 3, 4, 5, 6, 7, 8, and there's my octane. If I want, I can number them 1, 2, 3, and not miss out any numbers this time. And now I have to put the functional groups in, but it tells me exactly where they are. So diethyl, 1, that's not very good, is it? 1, 2, and I know that doesn't look very pretty, but it's okay. And then 2,2,4,4 tetramethyl. Tetra means 4. There's 4 methyl groups there. 2 of them are attached to carbon 2. 2 of them are attached to carbon 4. Ugly, but effective. Okay, so what I'm going to do now is make another couple of videos, one for the second page of the worksheet, but you only have to do that next week, and the other one for the third. They have a few complications in them because the second one has the double bonds, and there's an issue with cis and trans you might have seen. So we'll cover that in the next video, and the other one starts to look at cyclic alkanes, and that really does give us a bit of a headache if we haven't seen those before, but they're really easy. All right, so good luck with those, and see you soon.